our topic is glass electrode. Glass electrode is an indicated electrode which is used to measure the concentration of H plus ion or any other cation in the given unknown solution. The glass electrode which is used to measure the concentration of H plus ion in the given unknown solution is called pH glass electrode. In this lecture, I will explain the construction of glass electrode and how it is used to measure the concentration of H plus ion in the given solution. So let's start. A simple glass electrode is consist of a simple glass tube which is fused with a bulb of glass membrane. The glass electrode is filled with saturated KCl solution and 0.1 molar HCl solution. This glass electrode also contains silver chloride wire which is used as an internal reference electrode. The glass membrane is made of amorphous silicon dioxide which also contain some embedded alkali metal oxide. So when this glass membrane is placed in a given unsolution, so it absorbs H plus ion from that solution and got protonated. So this is the mechanism how they specifically absorb the H plus concentration. Right now, how it is used to measure the H plus concentration. So when a glass electrode is placed, when it is placed in unknown solution containing H plus concentration, so the H plus concentration on both sides of the membrane is absorbed on this membrane. So let's say there are more H plus concentration in the test solution than inside of the silver chloride glass electrode. So you can say on one side there are more H plus concentration, on the other side there are less H plus concentration. So if I should say a potential is developed, a boundary potential across the ion selective membrane is developed. So the concentration of H plus ion in the test solution will depend on this potential which is developed across the glass membrane. Now the question arises, how to measure it? Because if you see this system, if you observe this system closely, so there are a number of potential difference. There is one potential difference in AgCl and KCl solution here. The other potential difference is because we can't measure the potential of a single electrode, so we have to couple it with a reference electrode. So there is a potential. Let's say we use saturated column electrode, so it has a potential. You know that a saturated column electrode is made of Hg liquid on which there is mercurous chloride, and has a saturated you can say KCl solution. It has a center glass disc which has a contact with the test solution. Now how to measure the potential across this boundary, right? So the answer is, if we keep this potential constant, this potential of silver chloride potential constant, so if we know this potential and it is constant, so if we put this system in a test solution, so the potential change will be actually the potential across this electrode, right? So the main point is to keep all other potential constant except the potential developed across this boundary, so we can calculate the given H plus concentration. So a simple glass electrode consists of saturated column electrode SCE. You can see the makeup of it is Hg/Hg2Cl2 KCl, which is in contact with test solution here, right? If it is like this, excuse me, and then there is a glass membrane, and inside this glass membrane is 0.1 molar HCl solution, and we have AgCl and Ag electrode. So if we kept this potential constant and also this potential constant, so this potential, which is the boundary potential, can be measured very easily. Now, how to measure the potential across this membrane? So we know that E cell is equal to E right minus EL. E right, we have saturated column electrode minus E glass electrode. Glass electrode potential is equal to E glass is equal to E boundary potential, E silver chloride potential plus E symmetric potential. What is mean by E asymmetric potential? This is the potential due to strand defects in glass membrane, which is present in the given ion selective membrane as a intrinsic property. So it can be removed by connecting this glass electrode with another glass electrode, right? So the Nernst equation for boundary potential will be EB is equal to E out minus EN. E out is the potential outside the glass electrode and En is inside glass electrode. Let's assume Cn concentration inside of H plus concentration is less than concentration outside. So EB will be equal to 0.0591 log H plus concentration. We have just applied Nernst equation on it, minus 0.0591 log H plus N. So this concentration is concentration out. This is N plus E potential of AgCl plus E symmetric. As you know, the concentration inside is also constant, so this potential is constant. AgCl, because the concentration is constant inside the glass electrode is constant. Our E symmetric is already calibrated and it is constant. So Eg is equal to 0.0591 log H plus constant. From where? Okay, so log H plus, as you know, minus log H plus is equal to pH. You already know that. So we replace this log H plus by pH because there is no minus, so we have to put some minus here, plus constant. So the potential of E glass depend on some constant potential of the silver chloride electrode and E symmetric plus minus 0.0591 pH, which entirely depend on the H plus concentration out in the test solution. So E cell will be equal to E saturated column electrode minus E glass, so which is equal to minus 0.591 pH plus K. So E cell is equal to K minus 0.0591. So from this equation you can measure pH of a solution, right? So the basic concept here is that keep this potential constant, keep this potential constant, so this potential will be constant. Then put it in a test solution, so there will be a potential develop across this membrane on the both sides, and that potential will depends on the H plus concentration. So if we keep all other potential constant, so what does it mean? So the potential change will be equal to the potential developed across this membrane, right? So this is how we can measure the potential across this membrane. Okay, let's summarize the whole lecture which I have discussed with you. Glass electrode. Glass electrode has been used for measurement of pH and the activities of alkali ions since the 19th century. A glass electrode measures the pH of a solution by developing a potential difference across an ion selective membrane, right? The pH sensing ability of the glass electrode stem from the ion exchange property of its glass membrane. Glass is mostly amorphous silicon dioxide with embedded oxide of alkali metals. When the surface of glass is exposed to water, some of SiO groups become protonated, like SiO plus, here is a minus, plus H3O plus ion, so it will form SiOH, got protonated plus H2O. This is the basic of the ion selective adsorption of the that glass membrane, right? So this exchange of H3O ion between the solid membrane and surrounding solution and its equilibrium nature is the key principle of sensing. That's how a glass electrode senses H plus ion or any other alkali ions, right? Okay. Other points here are the potential developed across the glass electrode is the measurement of this potential will measure the H plus concentration. The glass electrode is coupled with reference electrodes such as saturated column electrode or silver chloride electrode. Why? Because we cannot measure the potential of a single electrode, right? The potential of a reference electrode and that of glass electrode is kept constant by keeping the concentration constant. By standardizing it by taking a standard solution of known H plus concentration in place of टेस्ट सोल्यूशन, पहले इसको स्टैंडर्डाइज किया जाता है. टेस्ट सोल्यूशन का H प्लस कंसनट्रेशन मालूम करने से पहले इसको एक नॉन H प्लस कंसनट्रेशन में डिप करते हैं और इससे कंसनट्रेशन जो पोटेंशियल कांस्टेंट मालूम किया जाता है. द मोस्ट इम्पॉर्टेंट पॉइंट इन दिस होल लेक्चर, द पोटेंशियल ऑफ द whole cell will be equal to constant potential plus RT NF log H plus. We have to keep all other potential constant except the potential across the membrane. So the change in potentials depends only on the potential difference across the membrane, which is in turn on the depends on the H plus concentration of the test solution. So बाकी सब potential को हम constant रखते हैं, सिर्फ the potential across ion selective membrane variable होता है और वो potential depend करता है H plus concentration पे. If we know that potential, we know the concentration of H plus ion in the given solution. So we know the pH of a solution. Thank you. That's all.